Are you guys having a fantastic day so far? I almost didn't make it because I fell on my behind at the station today. It's because I was wearing the wrong shoes, probably. So, but everything's okay. I was also here April just for a vacation, and I fell asleep outside the bar at the old city. I wasn't drunk. It was in the middle of the day, but remember this summer there was just so much sun, so beautiful. And if you've been living in Scandinavia for like 8 years, you know how precious the sun is. So when I came here and there's all sun, I was like, and then I sat down on a bench and I fell asleep literally. So it's so nice to see Stockholm in this weather. So I love it. I'm from the Philippines, so we don't get to see snow, and I'm very happy to see one, even though I fell on my butt. So my name is Marilag Dimatulac. I'm from the Wise APS. It's a company that I started about 2 years ago. We have a department in the Philippines and also in Copenhagen. Yeah, like I said, I've been living there for 9 years, and we're software engineers. We build web and mobile applications for enterprises, mostly in Denmark, that are also multinational companies, and then we also build our own product out of our own blood and sweat. It's not very easy, but that's what we do. And as a software engineer, actually still very much a developer, but also in charge of the different building blocks and making sure that these building blocks of the software works together and that we made the right choice. And the building block that I want to talk about today is identity and access management. Anyone working with identity here and security as developers or infrastructure? Okay, it's gonna be interesting. I'm gonna try to simplify because we only have 50 minutes and identity is quite a complex topic. So let's see how far we can go, and if there's anything that I wasn't able to cover or if I said anything wrong, please contradict me, because it's hard to um, remember everything in identity. Otherwise, we can talk outside and yeah, and continue the conversation. And the reason why I really like talking about identity is because of this. I don't consider myself as a super expert in security, because who else? Hey, who is, right? You've heard of all the collection one, collection two incidences where there's massive billions of user identities have been linked, and you've probably been pawned. You've heard of the service Have I Been Pawned, developed by Troy Hunt. It's a service where you can go in, type your password and or your username, and you can find out if your identity has been sold to the black market. And I can guarantee that all of us has already been sold, and that's a devastating fact, right? And this billion of unique combinations of email addresses and passwords pawned, that was just part of collection one. And I heard there's collection five. And over the course of the years, it's unimaginable how much credentials have already been leaked. And that's the reason why broken authentication and broken access control has always been in one of the top 10 OWASP, or Open Web Application Security Practices, vulnerabilities. It's just always there. We can't seem to get it right. I'm not saying that after this session we can get it right, but at least as developers, this is a developer centric session, we can find out what we can do about it now that we have the skill, and maybe now that the technology keeps on improving and evolving. Because honestly, it's very complex. Security is a complex matter, and security is not always just about authentication and authorization. There are many things that comprises security, but at least we're focused on how can we build our web and mobile applications to make it more secure. And the question that I always ask myself when I'm building an application is that, is my application trustworthy? Because it also reflects to us, am I a trustworthy developer? What am I doing to really make sure that the users can trust me? After all, they're giving out essential information about themselves. They are just handing out without complaints their addresses, their names, the name of their pet or their teachers from second grade, all these questions that we ask them and we keep them. So we need to safeguard it, right? So we need to be a bit more trustworthy developer. And trust is not just about security, it's also about simplicity. Because for the users, it doesn't matter. Sometimes, of course, they want it very secure. But if it's way too secure, which is not usable because it's just way too complex for them, then they're also not going to like it. Then you're not also going to get their trust. They're not going to use your application if you have to ask them 10 different questions that to be able to just prove their identity. So it has to also be simple, because simple for users is that you can sign in once, you can sign it anywhere. if it's a business application, I want to be able to use my apps if I'm at the office or even when I'm outside the office. I want to be able to access my resources. I want to be able to do my job, or if not, if that's not a business app, maybe a consumer app. I want to be able to do this anywhere in the world. And we need to make it simple for them, but at the same time without sacrificing security. And when we say secure, we need to build a system that is both preventive, detective, and corrective. When we say preventive, is that we put all our powers just to be able to avoid those breaches that we have seen before, like use the standard security best practices, make sure that our encryption is the proper one when you store passwords, that is using the latest hashing, advanced hashing mechanism or cryptology, and using salt and all these things. And if we want to implement login, that we make sure that we use multi-factor authentication. Some of these basic things that we need to put in place just to make sure that no breach gets through, no attack gets through. That's an ideal world, but because as you can see, it's not always the case. There's always an attack. There's always a breach. So a secure system also able to detect whether there has been breaches and able to react. And the way to do this is to put up some tools to be able to analyze what's going on, audit logs, logging, advanced analytics about the patterns that the user are doing against your system. Because whenever the protection you get is when once you detect an anomaly, an attack, you can react, you can be corrective, because you can't just bring your system down. When something bad happens, you need to get backup. You need to have the right facilities to be able to just, you know, rise from the ashes from this kind of breach and then move forward. So you need to put corrective systems in place. And that's so security is not just being able to block attacks, it's also being able to recover from attacks. And the way we can build something like that is to make our identity and access management system robust and efficient. But what is really the core functionality of an identity and access management system? At its core, of course, you have the authentication. What is authentication? It's proving that the user, or maybe a service or a device that's trying to access your system, is who she or he really says he is. And this we have done for so long via the virtue of secrets, which is just password. I know it's not very effective, but that's what we're doing right now, right? So you have to verify the identity of a person by checking the something that you both know that you promise not to tell anyone, but you do anyways. So something that the user know, or maybe something that the user have, a token, a device that can prove that that it's you're the real person. And maybe it's also something that you do, a gesture, right? And when we open our mobile apps right now, it's the pattern. So it's something we don't, it's not a string what we remember, but it's something that only us can do. Unless you do hearts in your mobile phone, then everybody knows that. So it's also something that we have that is biological. So with the biometrics, our eyes, our fingerprints, this is something that we can use so that the system, the identity and access management system, can prove that you're not an imposter. And that's just authentication. And once the user has been authenticated in the system, it's the also the role of the IAM. I'll just call identity and access management IAM. It's okay. So IAM to establish the session so that you don't always have to authenticate whenever you're accessing different parts or resource in the application. So you have to maintain that session. It's also the responsibility of the IAM to end the session or prolong the session and all this, and implement policies against how long the session can be. And then we go to, once you are authenticated and once you have a session, then based on the attributes that you claim you have as validated by the IAM, you can already access specific parts of, or very specific resource in your application. So maybe, you know, as an attribute, an example of an attribute is the department you're from or your role in the organization. And based on that, maybe you can access one part of the application and not the other part. So that's just basic authorization, right? And it can also be, it doesn't have to always be a role or an attribute. It could also be a context. Where are you accessing the resource? what time is it in the day, what month is it in the day. You can also right now with the advanced what you call adaptive access management, you can change the authorization rules just not only based on the claims but also based on the environment or the situation. And that's advanced authorization. And then, of course, to be able to make everything work, you need the actual identity management where you store the user profile or the device profile or the system profiles or the application profiles in a central storage. And then the IAM should be able to manage all the creation, update, and deletion and maintenance of all these participants in the whole authentication flow. So this is something that we have to implement. But under the hood of all this, it sounds simplistic and we see it every day, but there's a lot of things going on. There's a flow that's been going on to be able to implement authentication, authorizations, and session management. And it's not always trivial, and it's not only one way. And over the years, it's just been changing and able to for us to adapt to the changing landscape, to the changing situation on the way we access our applications. And they're never perfect. And some of them are just disastrous. And we implemented them anyways. But we learn our lessons. And like I said, what we do is we just have to be corrective once we find out this is not going to work. So as developers, we probably don't have to go very, very deep into the protocols around authentication, because sometimes all we needed to do is to understand, okay, what am I going to do in my code just to be able to instantiate the whole authentication authorization flow, right? I have so much in my head already. I cannot accommodate understanding all the complexities of authentication and authorization. But for a certain level, it would be nice to understand the terminologies, because that also makes us responsible for the things that we write. And even though we can just take boilerplate code, then when we read what that code is doing, if we don't understand the protocols, then we're at a loss. And if something goes wrong, it's either we just say, let's just see if there's a breach of all my identity. Why can I do everybody? It happens to everyone. So we need to have a certain level of understanding of these protocols. So to be able to show that, I'd like to draw it, which is very, very brave of me, because you have to. I'm not a very good artist, but let's try. I think I'm going to do this. Okay, so in the beginning, we have this user, this guy, who wanted to access an application. And in the very beginning, it was just a single user profile store. And to be able to authenticate, the app checks the user profile store for the credentials and then say, okay, you gave me the right credentials. So that's just the classic username password flow, right? And in the terms for web application, that's just your forms authentication. Very simple. Gets a little bit complicated when we started building more apps. And each of these apps also started building their own user profile store. And the poor user had to log into everything. And he didn't like that. So it's like, come on, guys, you're smart enough. What can we do? So maybe we can have this guy who's all-knowing and could replace all this and could just vouch for the identity of this person or this user so that he can, again, access all the apps. And this is what we know now as the domain controller, or which is a central repository. It's the guy that knows everyone in the organization, right? Very powerful guy. If you pull the plug out of that guy, everything breaks. So if I log in to my PC, for example, then I check the domain controller and I said, okay, I know you, and I'm going to give you a ticket so that you can use that ticket whenever you're trying to access all of these other applications. And this worked, and this is what we call the Windows Auth, right? Powered by Kerberos. I'm not going to explain the whole infrastructure underneath Kerberos, but you just know that it's a ticket system that you get so that you can transfer it to all the other applications, and then you can single sign on to these applications. So this worked for a period, except that this was limited within a domain, within your Windows domain. And then we fancy humans decided, but I don't want to just access the apps inside my domain. I also wanted to access my apps on other domains. And maybe starting in the 90s, I also wanted to access the apps in the internet. But this guy can't do that. It's limited by the network. What are we going to do? And then we smart humans devise another way, a new protocol to be able to ensure that we can still authenticate outside the boundaries of the network, outside the boundaries of the domain, and invented a new super god called an identity provider, which says, okay, you app, if someone tries to authenticate to you, call me. And here are my details. And so that you'll be sure that I'm the real identity provider, I'm going to sign these details with a private key. So you can, and I'll give you the public key so that you can, when you receive my details of how to contact me, you can validate that it is really true. And this is made possible by an X509 certificate, right? Within the IDP. And this is now, this app here would be called a relying party that the user would try to access, right? So when the user tried to access, okay, I'm going to call this guy and you need to first authenticate against this. And then when the IDP can authenticate this user's identity via maybe checking its own store or other IDPs, it will give a token that says, okay, you're good. You can access this app already. And this token, of course, is also signed by the IDP. It's not just a string. If it's just a string, anyone can produce a string. It has to be a signed string, which you could also verify via the keys, right? And that token also doesn't only contain a checkmark that, okay, this guy is already authenticated. It also contains signed attributes about this guy. Okay, I can vouch that this guy's name is Roberto and that he's from HR department. And you can see I signed it and you can verify that. So now that kind of signed attribute is called the claims. And then this app can use the claims again to be able to, to do authorization. And that works fine. So this is what essentially we call the claims-based authentication. And the claims-based authentication is not the protocol. It is just the standard. And the protocol that implements, there are many protocols implementing claims-based authentication, but the most popular one is SAML and WSFed. Heard of these protocols, right? They're very popular and still very much used today. But there are authentication protocols, so it's very much used in bigger organizations as well, and I think also in government to do single sign-on. And that was okay for a period. So SAML, they're just difference in the way they describe this one is called the metadata about the identity provider, the endpoints that you talk, and also the format of maybe the token. For SAML is XML, and actually WSFed uses SAML token. And the claims in a SAML protocol, the claims that this token contains is called SAML assertion, right? So that was fine until us humans couldn't really be satisfied and say, but I want that when I access this app, it will do something directly to another app on behalf of me. And that's delegated authorization, right? And we can blame the social networks back in the mid-2000 for this kind of need because they wanted to be very fancy. They wanted to attract more users as much as possible. So you don't have to go to Twitter. I can do all the things that you wanted to do against Twitter. And this is one thing where we actually, or the security people did something wrong by introducing something called OAuth, not OAuth2, but OAuth, whereby, okay, I'm going to access your resource in application B if you give me your credentials. I promise I'm going to keep, this guy saying, I promise I'm going to keep your credentials so that when I access this, I'm just going to pass your username and password. I'm not going to do anything to it. Bad idea, right? Bad idea. So they decided, let's change that. And instead, let's have another demigod, an authorization server that could also do the supervision in this protocol. So what happens is, whenever I try to access this app, and then this app wants to access B, I would say, yeah, I'm going to direct you to the authorization server, and then tell him to ask you to consent to the operation that I want to do against application B. For example, post a tweet, And then until you consent, I'm not going to do anything. But then again, you're not passing, the user is not passing the credentials to, it looks better on my screen. Sorry about that. So the user is just not going to pass the credentials, but instead talk to the authorization server and then maybe sign in again. This guy validates the sign in and then say, hey, you also need to approve that you want this app A is asking you to approve or consent that he's trying to access app B. Are you okay? And I say, okay, I'll do that. Do that for me. And when you do that, the authorization server then issues an authorization token to A, which A can pass back to the authorization server to ask for an access token. And that access token is passed whenever I try to call B. And B would then validate that access token from the authorization server. Hey, this guy gave me an access token. Is this real? Yes. Then I'm going to allow him to post my tweets. And that is OAuth 2. And OAuth 2 is just an authorization protocol, not an authentication protocol. And what if we want to also use those tokens to be able so that B can identify who the user is? The access token doesn't have that information because it's just authorization. It just contains the scope that the user approved or the permission that the user approved, but not his or her identity. What are we going to do about that? Then another spin-off of a protocol, which is called OpenID Connect. OpenID Connect is just a layer on top of OAuth 2 to also enable the propagation of the user identity that accesses this app so that you can, again, based on the claims that you can extract from the token, you can do authorization on your side. For example, this app is accessing this API, and in OAuth 2, what the API is expecting is a token on the header, which is what we call the bearer token, in a format called JWT, which is JSON Web Tokens, that contains all these claims of the user. If it's OpenID Connect, it contains the claims of the user. If it's not OpenID Connect and just OAuth 2, but just the permissions, the list of permissions, and the things that this app can do against this API. And again, of course, even if JOT is again a string, it's always signed. And this API can always go back to, or should go back to, the authorization server to validate the tokens. And now we have a very abstract art. I better save this one so I can put it on a frame. It's a very simplistic one. There are a lot of different flows depending on what kind of application that we're working with and all these things. And there's also downstream connection wherein I connect to the app that connects to an API that connects to another API on behalf of me. So that's called an on behalf flow. For example, if this user access a web app and access their custom API, and that custom API wants to access Microsoft Graph, for example, then you would have this flow. And then you would be able to call again this server to be able to handle this flow, because that's part of the OAuth 2 specification. And then I can request a different type of access for this application to pass on to the third level downstream API. Do you have any questions? But it's nice to see the evolution of the protocol, right? So we developers, what are we going to do? We just want to make our application OAuth 2 compliant, OpenID compliant. Maybe if we want to support organizations that also has a SAML or WS fed, we want to also build that. So what do we actually do in order to build these things? First, we need to find out what is the scenario that we're trying to build. Are we building a B2E scenario wherein we have an internal app maybe that is servicing internal users within the organization, within the enterprise, either from work or school account or an organization? So are we building an internal app? Or are we building an app that's customer facing, wherein their identities is not stored in our in our own internal directory, but stored maybe either somewhere else, or that they can use they can use other public identity providers to log into our app, like Facebook, Twitter, LinkedIn, Google, whatever other identity providers. Or of course, if you're building B2C, you can also maintain your own user profile store for all your customers, and that is separate from your internal users. So is that the app that you want to build, or you want to build an application that can connect both to your internal users as well as to their partners? And this is also important because obviously they have different requirements and different specifications. And then we need to find out what is the application, what is the type of the application we're building, because based on OAuth 2 standards or OpenID Connect, there are different ways to handle all this authentication dance. Because obviously, for example, in a server-side web app, you can store some of these tokens in a cache, in memory of in your web app server, which you won't do if you're scaling your server, right? You have to have a scalable cache that you can get tokens from. And yeah, so are you building a web app server side that also connects to an API, or are you building the modern type of web application, which is a single page application, which is also essentially architecturally different from a server side application? Because in a SPA, when you try to request the token from your authorization server, what are you going to do? Where are you going to store it? Or how are you going to do this dance of refreshing the token in this? So it requires a different syntax, a different paradigm. And that's the same with native apps when you have your phone and maybe Windows apps. And there's other types of application that we're probably not going to cover, like, daemon apps, or just apps that are running in the background that doesn't have any user context. But the ones that have user context would be this. So we need to find out what are we building, because there are libraries and SDKs targeted for those. And then what platform are we using to build these applications? For mobile apps, are we using native iOS or Android? Are we using Xamarin? Are we using Cordova? Are we using whatever is hip nowadays? What's it called with the one that's Dart based, cross platform, Flutter or something like that? It's gonna be big. So what is it that we're using? Or if it's web app, are we using React, or forgot React Native? Are we using ASP.NET Core, a classic ASP.NET? Or when we're building SPA, we're doing it with Angular, we're doing it with React, or just vanilla JS, and things like this. And why is this important? Because again, you would have to expose some libraries that are very specific to the platform to be able to connect and integrate with your authorization server or with your identity management system or server. If you don't use a library, you have to code it your own. And many times these authorization servers or identity and access management systems exposes an endpoint that you can call, in a REST endpoint that you can just, not a REST, sorry, an endpoint that you can call to be able to request authorization tokens, request access tokens, request ID tokens, sign out a user, sign in a user, and all these things. So, or refresh a token. So the authorization server exposes these endpoints, and you have to know how to be able to call those endpoints and react based on the platform that you are working with. So back to the actual IAM. So you're building a web app, for example, right? Are we going to connect to an existing one that your organization was already using, or you want to roll out your own? Possible, right? You want to do everything yourself. You want to put up an authorization server that is OAuth 2 or OpenID compliant, SAML compliant, and WSFed compliant, because you want to be based on standard, right? You don't want to build the hocus pocus identity access management that is easy to hack. So you want to make it as secured as possible based on standard. You can, by pleasure, do it yourself. But then again, it's very complex. You have to have the right skills and the right expertise in security. But maybe you're a bigger organization that have a dedicated security, and then you wanted the full control over your IAM. You don't want to use any other product. Well, you can. That's possible. But otherwise, you probably would rely on some framework based on the platform that you're already working with. If you're working with, for example, ASP.NET Core, then you can use the ASP.NET Core identity framework built by Microsoft, just a library within ASP.NET Core that you can invoke. For example, if you just need a basic user profile, then you could use the built-in one, which would spoon a SQL database where you can store your users. And then ASP.NET Core has also built-in capabilities for you to authenticate at other identity social providers like Facebook, Google, or Twitter, or I'm not sure about the whole list, but this you can do against your code and use a framework. And if that's not enough, and you still really want to run a full-blown uh, identity management system that has, like I said, that is also based on standard and can do much more than what the framework does, you probably need a product. And products come in all different shapes and sizes. A product can be just a piece of software installed in your own server, or it's a whole shebang of both hardware and system produced by AI, sold by the vendor. So you can use a product, and some products are also open source. And the most popular open source identity management product is Identity Server, which is now on version 4. So you can use Identity Server to be able to implement this whole authentication authorization mechanism. And Identity Server is so popular that it's actually starting to be baked into the ASP.NET Core. So because you still need to configure Identity Server, for example, that product, you still need to understand um, the whole big picture, how to manage an identity server. Then maybe it will be easier for you if from your code, instead of learning a different way, that you can also use ASP.NET Core libraries to do that. I think they just announced that because otherwise you have to do something to be able to spin out an identity server. So again, identity server is something that you can run on your own premise, or you can even run in the cloud. But if that's not enough and you need something where you don't really want to think so much about it, you want someone else, you want the experts to do it for you. Because maybe it's more secure, maybe it's more practical for you, maybe because you don't have the security expertise, maybe you have some very very complex need for compliance, maybe you're working for a very large enterprise, then you would probably go for an identity as a service type of product, which is a cloud-based identity and access management system. So everything is being managed in the cloud. All this support for authentication, single sign-on, and the likes will be managed by this cloud service. And so those are your options. According to Gartner, that by 2020, 80% of the new access management purchases globally will be IDaaS. Today, it's just 50%. So the interest for going to IDaaS is growing precisely because of all these more complex needs for authentication and authorization. And another thing is because it's so ubiquitous, because it's just there. For example, with Microsoft, if you have an Office 365 account, then you already have an Azure AD, which is essentially an identity as a service. And when you're picking the identity as a service product, you have to look at these different factors. You have to factor in the features that they offer. Do they offer the scenarios that is built for what you need? For example, can they do B2B, B2C, or B2E? What kind of SSO can they support? Can they support SAML? Can they support Fed, OAuth, Connect, OpenID Connect? Can they support a way for you to, if you have on-premise directory or identity providers, and then you have cloud and you have a hybrid scenario, can they support that flow within this kind of landscape? Do they have very advanced adaptive access management? How's their logging? How's their monitoring? How's their whole ecosystem of this product? And then another thing is, of course, usability, because even if it's popped with all these advanced features, your identity as a service product, but it's so hard to manage. It's so hard to register users. It's so hard to register applications that will be authenticated. Then it's not going to work. It has to be a very simplistic management portal that you can use. Does it have an API that I can connect to? And how about the developer experience? That's very important because, of course, we have an IDaaS just to be able to authenticate our users. But at the end of the day, it's still the applications that will heavily use your identity system, right? So what are they doing for that to make the lives of the developers easier? What kind of SDK do they use to expose their capabilities to developers that's using different platforms? What is their customer support? How are they documented? Basic things. What is their roadmap, their track record? How are they innovating? As we have seen, it's always changing. Are they adapting to the latest trends? And what is their participation in the whole uh, system of authentication and authorization that's always just becoming more and more advanced and more um, demanding? And lastly, of course, you have to consider the pricing. Like I said, if you run your own, it's not free. Of course, there's a cost to that. People always say it's probably more expensive, but you have to weigh in the cost of running it in the cloud, having other people run it, or having your own team run it. Even if you just do it yourself from scratch, there's still a cost, right? But then with the pricing, you need to understand different pricing models for different IDaaS systems. Is it subscription based? Is it per transaction? Every time a user authenticates against this server, am I being billed with that? Are there different tiers where I can get from from free to basic to professional to enterprise? So because I don't need all the enterprise and fancy stuff that you're offering, so what are my options for the pricing? So these are the things. But sometimes, of course, picking an identity system is not just a developer's choice unless you're developing your own product. But then if it's for an organization, it's normally the entire strategic team that picks the identity management system for us. And for the developers, we just have to find out how to integrate with them. These are some of the most common IDaaS in the industry today. And this is from Gartner in 2018. So you have some of the leaders. I'm not trying to sell any of these products. I'm pretty agnostic. It's just that, so Okta is one of the most popular, one of the leader in IDaaS right now, and it's just an identity company. And Microsoft is, of course, coming second with their Active Directory and Azure Active Directory, right? And of course, but they're of course not just an identity company. They also have, as we all know, a lot of other products. You have Oracle, you have Ping, IBM, and many other visionaries. So they have different levels of maturity. So in the visionary, Centrify is also very popular, I think. And Auth0 is becoming more and more popular because this one is built with developers in mind from the ground up. But that means that because it's for modern developers, they're probably not supporting some of the more legacy type of protocols or single sign-on capabilities. So again, if you're just building a new product and it's probably just an isolated product, not an enterprise product, and you need an identity and access management, are you going to do it yourself? Are you going to use framework? Are you going to use identity server or other product that is either open source or that you can buy, or are you going for the cloud? If you do go for the cloud, most of these IDaaS have the same story for developing against it. First, you need to register your application inside the system so that the authorization server can recognize you when you try to connect, right? Not all applications connect. First, you have to register, and then the application gets an ID, a client ID, and then maybe a secret if you need it. So you register, and then depending on what you're building and what kind of platform, you download or you get an SDK or a library or an API, and then put that in your code and try to configure it first so that your app, again, specify the coordinates against your server, your authorization server, IAM, and then so that you can always connect, you can download the metadata, the thing that identifies the server with all the list of endpoints that you can call to be able to trigger all these authentication dance. So you need to just basically set up your application to be able to connect to your IAM. And then you start coding specific to what you're building. If it's a web app, for example, then how do you, or ASP.NET Core, how do you secure a controller? If it's a spa, how do you secure what do you call that in a spa? A route and things like that. And then if the basic setup doesn't fit you and you need to customize, you want to add more claims in the token, you want to change the branding, you want to change the flow, or do some fancy stuff in between the flow before you get to the app, then there are a lot of customization options. So what we can look at, because I work a lot with Microsoft, because we're primarily a Microsoft company, and this is a .NET user group conference, right? So let's focus on Azure Active Directory, or sorry, the Microsoft Identity Platform, and how we can integrate to it with our web and mobile apps. So, like I said, with the Microsoft offers three different identities inside its platform. You have the Azure Active Directory, where you have your organization and work accounts. And then you would have your personal accounts, which is the one you use for your Xbox or Skype or other Microsoft services. So Outlook, Microsoft.com, Hotmail, if you still have that, falls under personal account. And they have just launched B2C, which is for your consumers. So what we're going to do is a sample ASP.NET Core web app that calls a web API. So let's see how you can register your app, how you can configure it, and what do you need to do in the code, and maybe what do you need to change. So this is a sample application. I'm just going to run it so we can see what's going on. But I need to do it in an incognito. Not there. So as you can see, because I set it up that whenever I hit a controller, like the home controller in the web app, then I get redirected to the login page. So I'm no longer in my site. I'm already in Microsoft. And that's where I explain the whole protocol, where you get redirected to a place where you can sign in as a user. And I'm just going to sign in. Oops, that's the wrong one. Then it tries to authenticate, and then it redirects me back to the app. Now I'm in the app. This is just a sample app. Okay, so what did we do? First, we had to register our application. So now I am in the Azure Active Directory in Azure Portal. And under the directory, you have app registrations here. And what you would normally do is first, if you want to you have an ASP.NET MVC app that authenticates against your Azure AD, you register an app, you put a name, you specify whether it's a web app or it's native, and then you can specify a sign-on URL, which is where you get redirected after you have signed on. And that URL would receive the token that you can process within your code later on. So I have already registered that. So it's this guy. Wait, this is the preview version of the portal. So I register this application, and I have some of this information about the application, like the ID and then the tenant, and yeah, which I need to use when now I configure it from my code. So the first thing is, in ASP.NET Core, you have to add a package, which is ASP.NET Core Authentication.Azure AD UI. It's a NuGet package, and then it will install. And then you need to set up your coordinates for your server, which would contain the instance. Let me just have it. And then the instance you would find in these endpoints. If I click the endpoints, you can see the different endpoints that I need to call in order to trigger some of this authentication dance. But what we need is just the instance, which is this one. It's pretty fixed. And then we also need the domain of the application, which is this one. And then you could also see in this that there's a tenant ID and there's an application ID. So those are this one. And this, you needed just this callback path, which you also register, right? We will get back to the secret later. So those are the things that you need to pass. And because we're using a library or a service already within ASP.NET Core, we don't have to do all the calling to the endpoints. The library takes care of it. So what happens next is that in ASP.NET Core 2, you set up your middleware, and say, your pipeline, and I'm gonna say, my pipeline, I wanna use authentication, and then you configure your different authentication services. You're saying basically add authentication that would use OpenID Connect, and these are some of the options or parameters that I need to pass in order for the OpenID Connect to work. So basically, I'm passing an authority, which is the how do I connect to that endpoint, and the authority is a combination of your instance name, which is login at Microsoft.com slash your tenant ID. And so it depends. These things change depending on you want to just authenticate against a personal against just the existing tenant, or if you want to authenticate against multi-tenant or everyone that has Azure AD, or also include personal accounts. So some of these are boilerplate codes, but it change depends on your use. And then the classic way of securing a controller is that you put the authorize attribute on your controller. So whenever the app hits that controller, it triggers the whole magic and saying, I challenge you, you're not authenticated. I'm going to redirect you to the authentication server. You need to sign in. Give me my token. Is this token valid? Okay, it's not expired. No, you can access me. Things like that. So if I want to access also an API, I need to also register that web API in the portal. That's why also I have it here. And almost the same process, except that after you have registered the API, you have also to tell the other application, which is your web app, to say that, okay, I'm going to give you a permission to access me. And what happens is that when, I'm just going to go towards code because we're running out of time. What happens is after I authenticate, you can see the code here, I said that after I have received an authorization code from the from the server, I want to acquire the token that I need to access the API. So your token for authenticating to the web app is not your token for the API. I have to first acquire it, and then you would have the check if, okay, what are you trying to do to that other API? What kind of scope you're asking me? So the user needs to consent. Maybe your admin can consent for all the users so that the users don't see that consent box. So some of these parameters you can configure as well. And then when I receive that, there's a bunch of calls here to be able to call use the library to call to pass your client credential, which is your app ID and your secret, and then basically just request an access token for the API. But the API itself doesn't have a user login. So when I hit a controller in the API, let's look at the API. This is the coach. This is the API for retrieving all the codes, right? It's also authorized, but it doesn't have a login page, the API. If you just access that directly, you would get an unauthorized. So in OAuth 2, what it expects is the JOT bearer token in the header, which your web app passed on every call to the API. So whenever you have an HTTP call from the web app to your API, you pass this token you retrieved from the authentication server into the header. And that's why in your API, you would set it up a little bit differently than when you did with your web app, because you essentially say, this is not OpenID Connect. This is my authentication scheme is not OpenID Connect. This is a JOT bearer. So it expects a JOT token. And of course, you still need to configure how do I validate and verify this JOT token that I'm receiving from this app. I need to contact again the authorization server and check whether this signed string is actually valid, didn't expire, has the scope that I configured in the portal for this web app that's accessing me. And then the magic happens, and then you get to retrieve your data. So that's how it works. For one scenario, other scenarios, I don't know if you have 1 minute. And the last sample scenario is, what if it's a native app connecting to B2C? A little bit similar scenario, but then of course here we're not using ASP.NET Core, so you use another library for configuring Xamarin. There's Microsoft. Now I forgot. I just always call it MSAL. I think it's Microsoft Authorization Library for .NET, so you can do that in Xamarin. If you're also building web app, you can also use that. But now I have an app that also has a management portal. Besides my mobile app, I have a management portal and which is built in Angular. So I would need MSAL.js, and my backend API is not ASP.NET Core but Classic API. So here I don't have the .NET Core. I would need Owin middleware to be able to again do similarly what we have just done in the other scenario. And there are a lot of things that you can do with the B2C. Well, you can also you go into the portal and register it a little bit the same way. And I'm just showing you what it looks like. So all this that you're seeing in an app is not part of the app's code. It is a browser on the app that is displayed on under a system browser or an embedded browser in the app. But this is run inside Azure B2C's authorization page. That's where you sign in. That's where you would reset your password or sign up for a new for register for a new account, and all the other things that you do when you're trying to authenticate against your app. And this is just because there's a branding, this is just HTML. So in the management portal or the manager portal of your app, for example, if I go to Touchpoints that app, this is the spa, you have the exact same experience. And this is the exact same code base for what you also see within the app. Yeah, sorry, we ran out of time. So I had a lot of challenges, of course, and there's always challenges. Identity is quite complex. Sometimes there's insufficient resources out there. Even if you go and read at all the documentations of all IDaaS systems, they're just not enough sometimes, and you have to piece your code. And there are service limitations at the moment, but we shouldn't give up because it's our duty to our users to make them feel secured, protected, and feel at ease. So we always have to make them trust us. Thank you very much, and I hope you had a good lunch.